Hello grade 12s, we're going to be looking at some more optimization questions. I know, your favorite, right? It's actually, like I said, it's kind of fun. I quite enjoy these questions. It really pushes us, and we're not going to let the big mark allocation freak us out. We just know that there's quite a few steps involved, that's all. So let's have a look at our first question. A hat box, ooh, fancy, in the shape of a circular cylinder is to be constructed in such a manner that the sum, okay, that feels important, that the sum of its height and radius is 9, okay. Determine the radius for which the cylinder has the largest possible volume. Okay, so largest possible volume. That's giving me another clue as to what I need to do. Okay, so let's start off with, all right, so they gave me the volume of a cylinder is pi r squared times height. Okay. Now, clearly, we can't only use this. We need to do a little bit of substitution so that I can optimize. So I'm going to use this sum of its height and radius is 9. So you see that they gave us variables to work with over there. So the sum, we know we're going to add. The radius and the height adds up to 9. Now, if you look at the formula here for volume, we see that there's an R, right, for the radius squared, and there's an H for height. So I want to now rearrange this so that I could sub into this formula. But do you see the question is asking for the radius, which has the largest possible volume? So I don't want to remove R as a variable, right? I want R to be there, so that I can then solve for R. Do you understand what I'm saying? If I made R the subject of the formula, I would sub into R and then be dealing with H's. But the question is specifically talking about the radius. So I'm going to make H the subject of the formula, and I'm going to sub that into H. All right, so the volume is pi r squared times height, which we've now rewritten as 9 minus R. So I'm just going to expand the brackets here. So I get 9 pi r squared times by pi, oops, not times by, it's going to be minus pi r cubed. Cool. So this is looking awesome because now I'm only dealing with the one variable r. Remember that pi is not a variable. Pi is just a number. And now when they talk about the largest possible volume, remember in this section, we are looking out for words like maximum, minimum, because that is implying you need to find the derivative. So what we're going to do, we're not saying largest possible volume. Think about another way I could say this is the maximum possible volume. So I'm going to work out the derivative of this in terms of R, right? So that's going to be 18 pi minus 3 pi r squared. And remember that when we're finding a maximum, right, so for a maximum, for the largest possible volume, you let the derivative equal 0. So I'm going to have 0 is equal to 18 pi, I forgot an r, minus 3 pi r squared. Okay, and now I'm just going to solve. So I'm going to take out 3 pi r as a common factor, and I'll be left with 6 minus r. All right, so therefore r is going to be equal to 0, or r is going to be equal to 6. Obviously, we don't want a radius of 0 length. So there we go. Determine the radius for which the cylinder has the largest possible volume. That would be your answer. Easy, hey? All right, let's have a look at our next question. So it says we've got a diagram. We've got this point C, X, Y, a line segment AB where we've got the coordinates of A and B given to us. COD is a right-angled triangle with D on the x-axis. Okay, so this length here, OD, I can label as X, and CD I can label as y, right? And that's going to correspond with that coordinate there, right? Okay, so what do they want to do? A maximum area. So we know we're going to let the derivative equal 0. We need to find the value of x for which the triangle will have a maximum area. Okay, so you may feel like in this question you have been given so little to work with. I know some of you are going to be wanting to think of C as like the midpoint and then maybe get that coordinate and go from there. But did they tell you it was a midpoint? They most certainly did not, so please don't do that. Let's work with what we've been given. So they gave me 2 coordinates on a straight line. So I mean, already I know, okay, let me find the equation of that line, AB. So let's find the equation of AB. So y is equal to mx plus c. We know that the value of c is 9, your y-intercept. To solve for the gradients, write your gradient y2 minus y1 over x2 minus x1. Your gradient is -3/4. All right, so the equation of AB is y is equal to -3/4x plus 9. Okay, so we've kind of now set ourselves up a bit because we can sub something into this height of this triangle now. Y is -3/4x plus 9, right? Because that's the point on this line, which is also a point on the line CD. So I can we'll call this length -3/4x plus 9. All right, and then I'll just be working with the letter x's, which is kind of what I want to do. I don't want 2 variables. All right, so we can say that the length CD is equal to -3/4x plus 9. Okay, so now I've rewritten y as something else in terms of x, because then I can find the derivative to be able to find that value of x. So I now know that the area for the triangle COD, area is a half times base times height, right? Which I've labeled x and y. So it's going to be a half times x times, well, we just said that y we can rewrite like this. Cool, so now let's just expand that bracket. So it's going to be -3/8 x squared plus 9/2x. All right, so that's how we can represent the area of the triangle in terms of x. Now I'm going to find the derivative and let it equal 0, and then I can find that value. So the derivative, so I'm going to say the area, like that, area prime equals 0 for max, all right? So I'm going to have 0 is equal to, all right, so that's going to become -3/8 times 2 is going to be -3/4x, plus that will just be 9/2. Oh my word, and this is like a linear equation, how easy. So 3/4x is equal to 9/2, therefore x is going to be equal to, so that's going to be 9 times 4 is 36/2 is 18 divided by 3, x is going to be 6. Okay, right, and yeah, that's your answer. So again, let's not let the high mark allocation freak us out. We literally are doing, I mean, this is like grade 9 work, right? Getting the equation of the straight line. It was just this idea of y is then that length over there, which I think would catch people out. But remember, this section, why I say these questions are so cool, is because it's this a part of your math paper where you really get to play. So just fiddle around a little bit, see what you can get, and eventually we get to this kind of setup, right, where we can find a derivative, let it equal 0, and then solve. All right, next question. Right, let's have a look at this one. In the diagram, it shows a solid right circular cone that is set centrally within the hemispherical container. Okay. the radius is 5 root 3. Okay, so this here would be a radius. The slant height of the cone, right? This length here, that would also be a radius. Coming up from the center like this, that would also be a radius. Okay. You're going to see why I'm doing all of this now. And they said that those lengths are 5 root 3. Of all possible right circular cones that can fit into the hemisphere, calculate the value of x, the height of the cone, okay, for which the cone will have a maximum volume. Let the radius of the cone, so that's that length over there, be equal to p. Okay, so let's have a look then. This looks suspiciously like a right angle triangle. Well, it's not suspicious, it is a right angle triangle. And remember that I said that this length is 5 root 3. Well, that's what the question told us, the radius of the hemisphere. So now you also probably want to label this as 5 root 3. But just see where I'm going to go with this, and maybe we can actually come back and check if that will work. So since I see that right angle triangle, I'm going to use some good old Pythagoras. How the hypotenuse squared is the side squared plus the side squared. So that's going to be 25 times 3. So 75 is going to be equal to p squared plus x squared. You now need to decide, what should you let be the subject of the formula? What are they asking you to find? They want you to find a value of x. So you want to sub in so that you have x's. When you sub in, you're left with x's. So I'm going to make this p squared be the subject of the formula. All right. So now what else did they give me? They gave me the volume of a sphere and the volume of the cone. Well, I don't think using the volume of the sphere will be valuable here. Let's rather use this formula. All right, so the volume of a cone is equal to 1/3 pi r squared times the height. All right, so the trick here, right, remember we said that p squared is, remember that p is the radius, right? That's what the question gave us. So into r squared, I'm just now going to sub this 75 minus x squared. Cool. So I'm going to say, therefore, the volume is equal to 1/3 pi r squared, which we are now taking from above, the 75 minus x squared, times by the height. Well, we actually also labeled the height as x. I've just noticed this thing in the background here. What is this? Okay. That's strange. So let's keep going. We need to simplify this. So the volume is equal to, by multiplying in, right? So that's going to be 25 pi minus, but we should multiply in the x as well. Okay, so let's go 1/3 pi, 75x minus x cubed. So therefore the volume is going to be 25 pi x minus 1/3 pi cubed. All right, so now we need to, what do we have to do now? We need to find the derivative and let that equal 0, and then we can solve for x. Okay, so let's find the derivative. So the derivative will be 25 pi minus, so it's going to be 1/3 pi, so this is 1/3 pi x cubed. So the 3 times 1/3 will just become 1, so that's going to be pi x squared. Cool. Now we let the derivative equal to 0 because we are trying to find the maximum value. And now we can solve for x. So we can take out pi, or we can divide through by pi. It's just a number, remember? So we're going to have 25 minus x squared. Well, that's just a difference of 2 squares. 5 minus x, 5 plus x. All right, so therefore, x is going to be equal to plus or minus 5. Obviously, we want to take the positive solution for x, for it to have the maximum volume there. Okay, so yeah, here was another one. Interesting, kind of, because it starts off so simplistically, right? Using just good old Pythagoras. What was tricky? Knowing that I needed to sub this in as is into r squared. So maybe the introduction of the variable p, maybe if they said let's label the radius as r, that would have been much easier to see that p squared is r squared, and you were like, oh wow, okay, I'll literally just sub that into there. But yeah, I think very doable and approachable question, and again, that's quite a nice, easy 7 marks that we can bank. Cool, next one. Okay, dokes, let's have a look at this guy. Busi and Kanye have inherited land from their grandmother. That's awesome. The piece of land is represented. Okay, so this is a piece of land. A, B, C, D. Beautiful. And rectangle. A stream can be modeled, which is modeled by the function. Okay, so that's a cubic function, right? This little portion over there is modeled by the function. Y is equal to 1 over 15 x cubed. 1 over 15 x cubed plus 3/4 x plus 3. For x is an element from 0 to 2. So they're just saying we're working just from 0 to 2, right? And that's the little part of the graph that I can see between x's from 0 to 2. And they tell us that f is 0, 3, and that e is 2 and 5 and 1/30th. Okay, cool coordinate. If we see a Kanye want to build a straight road, which is a tangent, beautiful. That's smart. So they're not letting the stream separate their land. They want to build a tangent here. So it can, for example, it would be something like this. Okay, I don't really know. We don't know the steepness of it yet, right? So this is just a good guesstimate as what this tangent could look like, all right? But they want to basically build a road, and they need to determine, right, well, we want to figure out who's going to get the bigger piece of land. So just by looking at it now, by eyeballing it, you're going to be like, oh, well, Busi got the better deal. But we need to show all workings because it is 7 marks. Okay, so yeah, no, this is so very different to the previous questions that we've done, but it's such a beautiful question. I'm excited. So they gave us y is 1 over 15 x cubed plus 3/4 x plus 3. Okay, we obviously want to figure out the equation of this tangent. That's where this question is going, all right? If I figure out the equation of the tangent, it's going to be very valuable because I can figure out what this point of intersection is over here, all right, which is then going to give me coordinates to work with so that I can then look at the separate pieces of land, all right? So we're going to have that portion at the top there, and that will be Busi's region. And what you should also realize is, that these lines are running parallel to each other. So do you see that I formed a little trapezium now at the top there? This is a trapezium because it's one pair of parallel sides. Okay, so I really need to get that coordinate where the tangent intersects the line BC. And then we can figure out the area. Well, yeah, the areas of the two different regions. Now we know that these are, since it's a rectangle, right, opposite sides are parallel, and we're going to be figuring out the area of trapeziums. Okay, but we'll get there. All right, so, okay, we've got to get the equation of this tangent. So let's think, what do I need to do? I need to find the derivative. All right, so that's going to be 3 over 15 x squared. So that's a fifth. X squared plus 3/4. All right, constant falls away, and we're just left with the 3/4 there. And we know that the x value at this point, right, at f is 0. So we're going to sub x equals 0 into this. And then what will be left over will be the gradient, which is just going to be 3/4. All right, so remember that when I say dy over dx, when I say derivative, we know that that also means the gradient. Okay, so the equation of tangent will be y is equal to 3/4 x plus 3. Okay, remember that f is the coordinate 0, 3, and you can quite clearly see that that is the y-intercept of your tangent. They told you that it goes through that point. Okay, so now we've got the equation of the tangent. Where do we go from here? Well, remember I said it would be lovely if I knew what this, so not E, we know that E is the 2 and 5 and 1/30. That point of intersection, we want to determine what that is so that I can then see what these lengths are, and then I can figure out the areas of these trapeziums. So it's this line BC is just the line x equals 2, right? So I'm going to call this point P, that point of intersection. So we know that the x value is 2. I just need to figure out the corresponding y value. Okay, I'm going to get rid of this. Doesn't really need to be there. Okay, so I'm calling that point of intersection that we are determining now, I'm calling that point P. We know that x is 2. I need to find the corresponding y value. So we're literally just going to sub x equals 2 into here so that I can figure out that the point P is 2, and then we'll find out what the y value is now. So y is equal to 3/4 times 2 plus 3. That's going to be 1.5 plus 3, so that's going to be 4.5. All right, so that point of intersection, which I'm calling P, is 2, 4.5. Okay, I'm going to write it like that. Jokes, 4.5. Okay, this is terrific because now you know the lengths of the sides. Okay, so let's start off with Bosie's region. Okay, so I told you it's a trapezium, hey? So the formula for finding the area of a trapezium is area of a trapezium is equal to a half. It's the sum of your parallel sides, and you multiply it by the height. Okay, that's the formula for area of a trapezium. So it's a half the sum of the parallel sides. Okay, so from 3 to 8, well, that is 5 units. And then what was this? 4.5 to 8. So from 4.5 to 8 is 3.5 units. Okay, so that's going to be plus 3.5. And the height, well, that would just be this length AB over there. So the height for both these trapeziums are going to be 2. Okay, so I go a half times 8.5 times 2. Let's see what that is. That's 17 over 2, or 8.5 units squared. Did they talk about meters or anything? No. Okay, so we talk about units squared. Okay, so that's for Bosie. Let's check out what's happening with Kanye. It's Kanye. Okay, so Kanye's region. So I'm not going to rewrite the area of a trapezium. So it's a half times the sum of the parallel sides. All right, so from 0 to 3, obviously that's just 3 units. And then we're going to go from 0 to 4.5. Well, that's obviously just 4.5 units. And we multiply that by the height, 2. So this is going to be a half times 7.5 times 2. And that's going to be 7.5 units. So, I mean, units squared, hey? So, I mean, at the beginning, I even said we are eyeballing it, and we already rate Bosie got the better deal, which we've seen now through our workings. Okay, so we've answered the question, but let's just wrap it off. Therefore, Bosie gets the bigger region. Okay, we just actually got to remember to answer our question. All right, so yeah, I don't think particularly difficult actually this question, but you do kind of have to know where to get started, right? Finding the equation of that tangent was important, and knowing obviously the sum of the formula to find the area of a trapezium. Whoops, so you got to know this stuff, grade 12s. Okay, last question. All right, grade 12s, let's look at this last question. An oil tank structure consists of a cylindrical body. Okay, so that's this bit over here. It's a cylindrical body that has a length h meters and 2 hemispherical ends with radius r meters. Okay, so the 2 hemispheres, obviously you realize that the 2 hemispheres, you put them together, you have a full sphere, right? So we're working with a full sphere and the cylinder. It has a volume of 1,000 meters cubed. Okay, so we're going to start off using this information here, these formulae, because they spoke to us about the volume being 1,000 meters. All right, so we obviously need to make that link over there. So let's add the 2 volumes together. The volume of the cylinder, pi r squared height, and we're going to add that to the volume of my sphere, which is 4/3 pi r cubed, right? And they said, right, when you add these 2 volumes together, you get 1,000 meters cubed. All right, so this is what information they've given us here. Okay, determine the value of r such that the total surface area of the tank is a minimum. All right, so we're solving for r in this question. So I want to make h the subject of the formula again. All right, remember that you want to be left with an equation which contains r's. So there's no point in me making r the subject of the formula. I'm going to make h the subject of the formula. So we're going to start off by subtracting this 4/3 pi r cubed on both sides. So we're going to have 1,000 minus 4/3 pi r cubed. So therefore, to isolate h, we're going to divide through by the pi r squared. So if you divide, if we divide the 4/3 pi r cubed by the pi r squared, right, you should realize what happens is the pi's cancel out, and you're just going to be left with 1r in the numerator. So h will be 1,000 over pi r squared minus 4/3 r. All right, so that looks awesome, because now what I'm going to do, I'm going to take this and I'm going to sub it in to where I see an h in my total surface area formula. All right, so the total surface area of the whole tank is a minimum. You need to realize though, if you think about surface area, so if you think about a Coke can, so a Coke can is a perfect example of a cylinder, right? But your Coke can has a bottom and it has that metal lid part, right? The 2 circles that are the top and the bottom. Or if you think of a Pringles can, right? You've got the lid on top of the Pringles and then you've got the metal bits at the bottom. So when we're considering the total surface area now for the cylinder, all right, you actually are going to exclude part of the formula. You're going to exclude the 2 pi r squared, this bit over here, because this is representing the area of the 2 circles. Remember that the area of a circle is pi r squared. So this part of the formula is representing the lid and the bottom of your cylinder. But those circles aren't going to be here because we've got those hemispheres on either side. So when we're working out the total surface area of the shape, the surface area is going to be the full sphere, right? The 4 pi r squared. It's going to be that surface area and that surface area to give you the full sphere. And I'm going to add the 2 pi r h from the surface area of a cylinder. So we are excluding that part because the lid and the bottom of the cylinder isn't there, right? It's hollow inside. So I have to exclude that part of the surface area. Okay, so there was the little catch. And now I've got something that I can sub into H so that I can just be working with R. Remember that pi is just a number. So your surface area will be 4 pi r squared plus 2 pi r H. H is 1,000 over pi r squared minus 4 over 3 r. Okay, and now we just need to remove that bracket, and let's see what happens from here. Okay, so the surface area will be 4 pi r squared plus, all right, so these pi's will cancel each other out and one of the r's. So it's be 2 times 1,000, so it's going to be 2,000 over r minus, so it's going to be 2 times 4 over 3, so that will be 8 over 3 and pi r squared. Okay, all right, so I just distributed into my bracket over there. Okay, so this is looking fine except for this middle term, right? You can only find the derivative if the variable you're trying to solve, it's in the numerator, right? So I just need to make a slight adjustment. And besides that, these are actually like terms. So I can add those two together. So on my calculator, I'm going to go 4 pi minus 8 over 3 pi. And that simplifies to 4 over 3 pi. So you're going to have 4 over 3 pi r squared plus 2,000 times r to the minus 1. All right, remember I took this term and I moved it into the numerator. So then our exponent will become negative. Okay, and guess what? We can actually find the derivative now. All right, so the derivative will be 2 times 4 over 3 is 8 over 3 pi r minus 2,000 r to the minus 2. So if we want to take that r back into the denominator now. So that's going to be equal to 8 over 3 pi r minus 2,000 over r squared. And remember that we let the derivative equal 0 for a minimum or a maximum area. Okay, I'm just going to scooch this up. I need some more space. All right, so let's multiply through by the r squared. So we're going to have 8 over 3 pi r cubed minus 2,000. Okay, so I'm multiplying through by the r squared in the denominator there. I'm going to have 2,000 is equal to 8 over 3 pi r cubed. I'm going to divide 2,000 by 8 over 3 pi, and that will equal r cubed. All right, so 2,000 divided by 8 over 3 pi. So I get that r cubed is equal to 238,73. All right, now we're just going to cube roots both sides. So we get that r will be equal to 6,20 meters. All right, okay. And does that answer our question in its entirety? Determine the value of r such that the total surface area of the tank is a minimum. Yep, that's it. Okay. All right, grade 12s, good job. I know this is not everybody's favorite section, not everybody's favorite question, but like I said, it's a really cool area of our paper that we really get to play and explore and apply some of this beautiful calculus that you have been learning. All right, thank you, everyone.